In this video, I'm going to cover how to use dimensional analysis for metric unit conversions. So my first example here is asking how many meters are in 12.4 kilometers. So we want to change from kilometers into meters. And in order to do that, you got to know how many meters are in a kilometer. So that conversion factor is given here. So I'm going to set up dimensional analysis. And what this is a way to solve problems by looking at the units of the given numbers and the desired units of the answer. What's nice about dimensional analysis is if you get good at it, it saves you from having to memorize a lot of equations and formulas and those sorts of things. So it's a good problem solving method that you can apply to a lot of types of problems. So to get started, I need to take advantage of the fact that anything divided by itself is equal to 1. So 15 divided by 15 is 1. 100 billion divided by 100 billion is 1. X divided by X is 1. Anything divided by itself is 1. So we're going to use that fact along with the units to do our conversion here. So I'm going to show you how to do this on the Google Docs as well, how you can type nice, clean, neat looking equations in here. So you can go to Insert and go to Equation, and this little equation box pops up, and then you have this equation editor toolbar. So what I'm going to do is I need to write this as a fraction. So I'm going to grab this guy right here, which is the fraction, and I'm going to start by putting 12.4 kilometers. That's the abbreviation there for kilometers, and I'm just going to put a 1 on bottom. That 1 is just a placeholder, so just put it there to hold up the kilometers. So I'm going to go ahead and hit my cursor to tab over, and it looks like my cursor has disappeared, but it's actually right here after my fraction. So I'm going to come up here into my operations bar and do a multiplication sign. And then I'm going to need to use another fraction, so I'm going to come back over here. Now, we want to write this so that the units of kilometers cancel and we end up with units of meters. So if we want to cancel out kilometers, should that go on top or on bottom? So what I'm going to do here is I'm going to go to the bottom of my fraction and I'm going to put 1 kilometer on bottom. Then if we want to change this into meters, we just need to know how many meters are in a kilometer, which you were given. So 1,000 meters is equal to 1 kilometer. So what's going to happen here whenever we solve this is the kilometer units are going to cancel out, and then the only unit left is meters. So basically I need to do 12 times 1,000. Which gives us 12,000. So here's my answer in meters. Now, does this make sense? We know that a kilometer is bigger than meters, so my number should get bigger, which it did. Let's look at another one that's a little bit more similar to what you're doing in this classwork. So a photon has a wavelength of 563 nanometers. How many meters is this? So then I give you a conversion factor. This is given to you in scientific notation because this is a huge number. You certainly don't want to write out all those zeros every time. So that makes sense because a nanometer is way smaller than a meter. So I'm going to go to Insert and Equation, and I'm going to go ahead and put a fraction in. And I'm going to start by putting my given, which is 563 nanometers. On top here, and then I'm going to put a 1 on bottom. Again, that's just a placeholder. Come over and put in a multiplication sign, and let's do another fraction. So we need to think about what needs to go on top here and what needs to go on bottom here so that nanometers cancels out and we get our answer in meters. So do I want to put this one in or do I want to put this one in? So think about it and show me your work in your packet or in your worksheet. Now, why do we need to change nanometers to meters? Why is that even a thing? So if you look at the units of these equations that we just went over, if you look at this one, velocity has units of meters per second. Frequency is per second, and wavelength is meters, it's length. So this gives us meters per second. But if you multiply frequency times the wavelength in nanometers, you're not going to get meters per second. You're going to get nanometers per second, which is fine, but we want to make sure that our units cancel out and we're looking for our answer in meters or meters per second.